Hello, myself A.B.DESAI. In this lecture, we are going to discuss about the DC circuit subject, chapter number 4, capacitor and electrostatics. So here is the syllabus of the chapter number 4. Name is electrostatic and capacitor. What are the various topics we are going to learn in this chapter, that is listed here. So we are starting our first topic, it is electric charge. So what is the electric charge? So before understanding the electric charge, we should understand about the fundamental particles, or we can say it is a elementary particles. So there is a main three fundamental particles: electron, proton and neutron. The mass of these three particles are given on the screen. So as we all know that if any body has a mass, it can exert a gravitational force because the mass is generating the gravitational field around the body. That is why it is can exert or experience the gravitational force. So when these particles are placed at 1 centimeter apart from each other as shown in the figure. In the figure, there is two cases shown. In the first case, there is electron and a proton. This electron and proton are at a distance d. At that time, they can experience an attractive gravitational force. In the second case, when two electrons are placed at some distance, they are also experience a gravitational force attractive in nature. But in the both the case, there is some other forces are also present. That forces are known as electric forces. Now the question is why these electric forces are present. So the presence of electric force in this case is because of the property of object that is called as electric charge. It is called as electric charge. So that is a definition of electric charge. Actually, we cannot perfectly define the electric charge, but for the understanding, we can consider this example. Now, we are learning the nature of elementary particles. So, these three elementary particles have the different nature: electron, proton, and a neutron. As we see here, the neutron has a zero sign, electron has a negative sign, and the proton has a positive sign. This zero, negative, and positive is defining the nature of these three elementary particles. The zero, negative, and positive have no any relation with the magnitude of this one. These are the simply nature of these elementary particles. Now, for the convenience, we are considering the electron has a positive sign, sorry, electron has a negative sign and a proton has a positive sign. If we are considering in the reverse manner, that doesn't affect the final result. And neutron has no charge. So that is the concept of charge. Now, what is the unit of charge? How we can measure the charge? So to measure the charge, we are using the unit that is called as a coulomb. Now, very first time, how we can define the 1 coulomb charge? So when there is 6.25 into 10 raised to 18 electrons are there, the charge of this group is known as 1 coulomb charge. 1 coulomb charge. On the base of this, we can find the charge on one electron and charge on one proton. Now here you can see that electron and the proton has the equal amount of charge, but they have the different sign. Electron has a negative sign, the proton has a positive sign. These negative and positives are just showing their different nature, showing their different nature. Okay. Now next is laws of electrostatics. Now in the first slide we will learn that what is the charge, and we were discuss about some forces are there. So to understand that forces, there are some laws. That first law of electrostatic is state that when two like charge are near to each other, they are repelling each other. When two unlike charge are near to each other, they attract each other. So that is the first law of electrostatic. Now here like and unlike, it doesn't mean they are equal. Like and unlike, that means they are equal in nature. Like two like charge, that means two protons are considered as a two like charge because they have the positive charge. One electron and one proton considered as a unlike charge because the proton has a positive charge and electron has a negative charge. Now, so the first law of electrostatic is used to determine the nature of force, whether it is repelling or attracting. Now the question is, what about the magnitude of force? So to understand and to find the magnitude of force, there is a second law of electrostatics. Second law of electrostatic is used to determine the nature and magnitude of electric force. This law is given by French military engineer and physicist Charles Augustin de Coulomb. So it is also known as a Coulomb's law of electrostatics. So in the next lecture, we will learn about the Coulomb's law. So